Hello everyone, welcome back to my channel, and this is part 3 for the vector database, and we are trying to learn the concept of vector database on Pinecone database, right? If you haven't watched my previous video, I would highly recommend you to watch part 1 and part 2 so that you have a little bit of understanding what we have covered so far. In the previous part, we try to understand how we create an index, so you can see the code on my screen. We wrote a code through which we created an index, and apart from that, we see some other functions like describe index, the list index where we can list the indexes, and then we try to delete the index, and there are few methods which we get when we try to make the connection to the index, which is upsert, query, fetch, and delete. So we're going to cover this upsert and query today. But to do that, we have to first store the data. And to store the data, we have to create the embedding of our data. And that is where this part is focusing on. So what we have to do, so real quick, this is our Pinecone. The website here, we can see these 3 indexes: tutorial, quick start, and compliance data. This looks good. And then before we get into the embedding, the very first thing we have to understand, what is embedding? I think I have explained in the part 1. Embedding is where you just convert your textual data, image, or audit, or any unstructured data into the numerical representation. And that representation, we call it as a vector because it is just a list of some numbers. And these all things we gonna see through the code, how we can generate that. To just generate the embedding, we have a lot of embedding models. So what we have to do, whatever the text data which we have to feed in that data to our embedding models, and that embedding model is actually going to generate the vectors for us. And if you just go here in Pinecone models, you can see there are multiple models, which you can use to create the embedding, right? And if you remember, or if you just see this code here, we have used this dimension is 1024. So we have to make sure we are going to use an embedding model which can generate a 1024 dimension. Otherwise, we won't be able to store our embedding into the index, right? So that makes sense. Now, what I'm going to do, so first I'm going to create another Python file, and I'm going to say create embedding. Okay, and I'm going to borrow some code which is common like until this point. Okay, so we are good. So we initialize. Okay, so this looks good. Now, what we have to do, we can just put this code as well as is, so that because it's not going to do anything because we already created that. So it is going to just bypass that, right? Because it's going to fail. We can just put that logic as well. Like, I mean, if we have an index name, so let's really quick do that. If index underscore name, and we know which provides us the list of index. So we have this method, right? So we can see that. Okay, so if it is there, it is going to true, then we can print out a way string requested. Right? So we can simply ensure. Okay. If it is not, then false. Okay, so this looks good. Now, what we're going to do here is we are going to write. So I have already written some code so that we can save some time. So this is what the data which I have created, and for which we're going to create the embedding. So let me just walk you through the data which I have created. This data is, we have an ID. So it's a JSON. It's a list of JSON where we have an ID and we have a proper text, right? So this is the structure in which we have to generate our data. And ID is like vec1, vec2, so vec3. These are the some ID. You can give any name, whatever you want. And then in text, we have a corresponding text. So for every line, we're going to generate the embedding. So basically, we are going to use a model which is going to take this text as an input, and it is going to generate the numerical representation, and that numerical representation will have 1024 entry because this is what the dimension we have for our index, right? So this is our data. Now, this is the embedding logic. Let me just quickly copy paste and let me just explain that. So here, if you just see what I'm doing with this Pinecone, we have this inference API. right? So what this inference API is, it's actually what Pinecone has done is Pinecone has already hosted all these embeddings. So we don't need to worry about running these embedding locally or hosted somewhere through which we can connect them. So Pinecone has since already hosted that to their server. So all they have given us this inference API. In this inference API, all we need to do is to just provide the model name, which is listed here in their website, right? So right now, what we are using this embedding, which is multilingual E5 large, right? So we can come here and we can just see what it is. Right. So ideally, if you just see the dimension is 124, 1024. So it's a general purpose, high performance while keeping the open source. So it's good, but we can just play with this. We can just use the different one if you want, right? But right now we just wanted to understand the concept so that later on we can just, use the different one depending upon what kind of use case we are trying to handle. The next is the embedding parameter. In embedding parameter, we have two tags, right? Input type. So in an input type right now it's passage. Passage means the text which we are feeding it. It can be a query when we are going to shoot a query, right? So if we want to first, once we store this data, then we have to do the query. So at that point of time, the input type is going to be query, but we're going to talk about that. Truncate is and. It means that we are just indicating, the truncation policy. Like, it should be and. Once this data is, it's nothing is there, then whatever the and for this particular text, it should be truncated. So it will be considering only the entire passage. Okay. So now this embedding input. So for creating an embedding input, what we are doing, we are just iterating through this JSON object, basically this list, and then we are extracting this text and creating a list of, right? So this is just a list comprehension through which we are creating a list of all the text. Right. So these are the three parameters which we need to pass in. So if you just see P, C, and then we are just calling an inference, and then inside that we have embed. And in embed, we have a model. So here in the model name, we are using multilingual E5 large, which is a general purpose embedding model and which provide a 1024 dimension. Then the embedding parameter, which tells us, okay, the text is the passage, and whenever the entire text is done, that is going to be the ending of the sentence or the passage. Then we have this embedding. Basically, sorry, embedding parameters, and embedding input is just the input, the list of text which we have generated, right? So once this embedding is created, we're gonna get this embedding. So now I'm just trying to print that out so that we can understand, right? So if everything looks good, then we should be having those embedding created for us. So Python embedding. Let's run it. Okay, failed to create index, which makes sense. It's already exists, right? So we should not be worried about that. Okay. Now we can see, all those values, but here's something is wrong because now it is getting into the loop where, it's not satisfying this condition, the index name, which is tutorial, and PC list underscore indexes. So probably we have to extend the name so that I can just quickly fix that. That's not an issue. We'll fix it, right? That's not an issue. We can just see what all information we are getting, and then we can just check that. So let's quickly print and see what's happening. Just fix that as well. Okay, so here we are getting the list, and inside the list we have the name, right? So we have to iterate through the list. And then we have to extend the name. Okay, so we have to just modify the logic. We'll do that, but I think that is not something which we should be worried about for now, because now what we are seeing here is now we are having a proper numerical representation for each and every text. So we have, these different text, right? So once we have this embedding created, right, what next we have to do? Now we have to just upsert the data. Upsert the data means we have to store the data, right? So this is where, if you just remember that in previous part, we just understood that we have one method which is called upsert, right? So now what we are doing here is we are just making a connection to the index, right? So creating an index, we have this index function where we have to pass in the index name. So now we have the connection to the index. And index, we have this upsert function, right? In this upsert function, we have two parameters which we need to pass. We need to pass vectors and we need to pass names. So what is vector? Vector is where we have to just create a data in a specific format, which you can understand here. So where we are just creating a JSON object, if you just see, and what we are doing here, we are having ID, then values, and then metadata, right? And to do so, what we are doing, we have this data, right, where we have the list of these JSON, right? We have ID and text, and then we have an embedding. So we are zipping that. Zipping means we are having a one-to-one relation. So basically what we're going to have now is we're going to have a data as well as our embedding, right? So it's just going to map directly one-on-one. Okay. So what next, right? So once we have created this vector with ID and then our values and then metadata. Metadata is nothing but where we have our text. Okay. So now what we are doing, we are just trying to upsert the vectors and the namespace. What is namespace now? Namespace is just a logical entity which is just a part of our index, right? So whenever we have to isolate our data, we have to create this namespace. So whatever the namespace we're going to pass in here, if it doesn't exist, it is going to be created by the Pinecone folder. So let me just define a namespace and I can say namespace is okay. So now we are able to add the data, right? What next, right? So we have to do that. So now what we are doing here is let me just but before we do so, before we do any query, let's try to get the index stats, right? So that way we will be knowing whether our data is uploaded or not, right? So let me run this one more time. Oh, I should have removed that. Okay, so now here we can see the stats, metric is cosine, the namespace is NS, the total vectors count is 17, so before we do that, let me just quickly delete this. So let me just run this so that we can have a fashion. Okay. So actually, I'm just trying to delete this because it seems like it is having some data and some data just not deleted. So now we are good and now we have to create embedding. So we should not get any issue. We have only two. The third one is created. Okay, so now this entire code will be run. So we have Upserting the query and we'll see what the rest looks like. Okay, so right now it seems like this is not yet updated. So let me do one thing. Come down here. Okay, so let me just download this code. And select this one. Okay, but I will be using index. So let's just copy this. I think by now it should have been updated. Okay, so let's run this page one more time and see the status. Okay, so we have tutorial and now we can see we have 20 records, right? So that's awesome. Okay, so we can see all the 19 records are there, right? So now we know what is embedding, how to generate that, what precisely, how we can upload that into the index, right? So we all understood the embedding and the concept of embedding, right? The another thing which I wanted to explain you, this website is really awesome, right? So all you need to do is to just go to the docs and then done, right? If you just come down here, there are a lot of code which you can use, like for observe data, query data, fetch data. In our next video, definitely we're going to talk about how we can, query the data, and how we can do the similarity search or the semantic search for this is the main purpose which we want to cover in this, right? So far we have understood the basic functionality of the vector database, then we create an index, and in this video we just created the embedding as well, and we just try to upload that, right? So let me just uncomment this piece of code because we are going to use this in a next video. Okay, so let me just remove that. In our next video, what we're going to cover, we're going to see how we can just query the data, how we can fetch the data, how we can delete the data, right? That is something which we're going to cover in our next video. So that's it from my side for this particular video. If you have any feedback or suggestion, please feel free to put that in the comment section. And if you really like this video, give me a thumbs up. And if you feel that okay, this kind of video can help your friends or your group, please do share with them as well. And if you haven't subscribed for my channel, please do so. And thanks for watching this. And as always, stay healthy and keep learning new things.